Good afternoon, everyone, or good evening, depending on the part of the world you're from. And welcome to the fourth talk in the Robotics Café series. Again, I think for those of you who've been attending for the past 2 or 3 weeks, you know how this goes. For those of you who are attending for the first time, welcome. So, as I was telling the speaker just before this starts, this is supposed to be an open forum where we roll up our sleeves and talk. The idea is that we get people from the academia, academics, students, folks from the industry like our speaker today, as well as hopefully someone from the government to present that perspective. So it's a place where we can talk freely, discuss. So at any point, feel free to ask your questions. I'm pleased to introduce our speaker today. Dr. Tanvi Prakash is an aircraft designer serving as Deputy General Manager for UAVs at Larsen & Toubro, a leading Indian defense contractor. She's an alum of VJTI from Mumbai. So that's where she got her first degree in mechanical engineering, and then from IIT Bombay Aerospace. She has received the prestigious International Academy of Engineering Young Associate Award and the Women in Aviation Harvard Scholarship for Emerging Leaders in Aviation. Her areas of expertise are aircraft design, new product development, and flight test engineering. Her most recent UAV development assignment was leading the design and development of Tir, a jet-powered aerial target UAV for the Indian Army. She led L&T's team across the entire development cycle, including design, prototyping, flight testing, and serial production. She also serves as a UAV test pilot, conducting trials across India for various defense customers across the country. So currently, she focuses on advancing innovative UAV configurations like tilt rotors, flying bullets, and morphing wings. So, Tanvi, thank you very much for agreeing to give a talk. Welcome, and you can start whenever ready.
Thanks for that very nice introduction, Professor Aditya. Today's talk is a very industry-specific and a very practical sort of talk. It's going to be about how exactly do you go about building a UAV. A lot of people here would be curious about this and how you actually can build a product out of it. How do you convert all your mathematical know-how, your R&D know-how into something that's actionable, that can be produced, that helps your customers. So without further ado, I'm going to share my screen, and I would request you, Professor Sujit, if you could please confirm that the screen is visible.
Yes, Tanvi, it's visible.
Okay, great. That's how I look when I'm on site flying my UAVs. I'm not going to get into this. And we hear these words like UAVs, drones, unmanned aerial vehicles, unpiloted aerial vehicles, remotely piloted aerial vehicles. And we wonder whether they're all the same thing. Actually, they're all different ways. Drones is another word. So they're actually all the same thing and different ways of saying that there is no pilot on board this flying vehicle. There not being a pilot on board could have two meanings. There's no pilot at all, or that there's a pilot on the ground or remotely somewhere else in a plane, on a ship, who's operating that aerial vehicle. So that's where the sort of boundary of an unmanned or uninhabited aerial vehicle is. How does it fly? Who designs it? And one of the biggest questions that a lot of students ask me is it a good career path in India? So we are going to look at all of these things and how to get into this field if you really want to. So I'll give you a brief about what UAVs can engulf. This term can incorporate so many sizes. You can see this is a mini UAV, what we call a mini UAV. It's about, you can see it's the size of the arm span of a human being, right? You could go smaller. You could have a UAV which looks like this, which is probably the size of, it can be held in between your palms. If you go even smaller, UAVs that are the size of your finger. That's a mini helicopter UAV with a camera for indoor surveillance. As you start going larger, you can see this UAV. This is an Israeli UAV which was operated by the Indian forces. This is a photo from one of the Indian hangars that's available in the public domain. This is the size. You can see the size of the humans who are working on it. It's about the same height as the human, you could say, in a way. And then you have the male or HALE UAV class, which are almost as big as a commercial airplane. And this is a photo that I like to show. This is also me for scale with one of the UAVs that I built for the Indian Army. This is the Tir class UAV. So UAVs can be so diverse. You look at all these different configurations and these different ways of flying. Some fly with wings, some fly with rotors, some fly with both. And they take off in different ways. Some take off from a runway, some take off vertically, some take off from a canister. They are shot into the air. They are used for a variety of applications. Of course, surveillance is the one that's gaining a lot of public notice because of how the geopolitical situation is these days. But also they are used for so many other activities like climate monitoring. The one that you see on the left is actually a high altitude UAV that's flying over a cyclone in the Bay of Florida. I mean, whatever you call it now. And then you can also have UAVs which are, almost like satellites, which are solar powered.
I think your screen sharing got stopped.
Let me share it again. Thanks for letting me know. So you can have solar powered UAVs for which are pseudo satellites, which can provide network in remote areas, things like that. Now, how do you actually go about doing this? And I like to break it down into a 10-stage process. Well, actually, I cheated. I added a stage 0, so it's an 11-stage process. So the first stage actually is innovation. I'll give you a moment to read this slide. Okay. This is from Calvin and Hobbes. It's one of my favorite comics. And do you think this is innovation? Really, I don't know if it's innovation, but definitely it's looking for a loophole, looking for something that you can change in. And UAVs, the way they have been developing over the years, have definitely shown this kind of spirit, where you find a small loophole and it's possible to take out an entire army tank with just a UAV the size of your palm. So the first stage is you have to think differently. Now, after this, you get serious. Now you start looking at what your customer really wants. You look at their requirements. This is called the specification generation or the concept of operations stage. During this stage, what you basically do is you look at it from a customer, from a user point of view, and you see what they want. For example, let me break down this requirement for you. At the bottom here, you can see there's a 2,300 foot runway that's available with the customer. The user wants the aircraft to take off with a crosswind component and clear a 50-foot obstacle across the runway, be able to take off in these conditions. After takeoff, climb to an altitude of 25,000 feet, then have a cruise climb, and then do a loiter at 15,000 feet for a period of 24 hours, and then descend back and land back on the same 2,300 foot runway, along with 1 hour reserve loiter at sea level. You need to first break down your customer requirements in this way so that you know what your aircraft is supposed to do first. This is before you even draw a single scratch of design on your paper. You need to know what your customer is expecting, what mission the aircraft has to fly. Next, now, here is where you can start ideating on what all are the different ways in which I can solve this problem of the customer. You can go for a fixed wing, you can go for a quad, you can start thinking of whether you want 4 rotors or 6 rotors or how it needs to look, what's the payload it needs to carry. And now, on the right, you will see that there are different priorities for design. At this stage, you need to kind of fix your priorities. For example, if you have, if your basic requirement is that this thing needs to be really low cost in manufacturing, then you will probably build it like this. If you want it to be super sleek and high speed, maybe it'll end up looking like this. If you want it to be very strong and rugged, then it'll end up looking like this. So now I want you all to get a feel that there is, sorry, Somebody just needs to be on mute, yeah. So now you'll get a feel that there is a wide variety of configurations that can be selected based on your priorities. So you'll start thinking about what, based on the concept of operations, what could be my end user's priority? Are any of these their priorities? And from this, you end up choosing a particular aircraft. Now, at this stage, this is when you start getting into performance. You start looking at lift, drag. You can start doing your flow analysis over the aircraft, trying to see whether you're generating enough thrust. The photograph on the right, this is one of the iconic aerobatic display teams of India. This is the Surya Kiran team. This particular aircraft is designed to fly upside down. So how do you calculate the performance of this aircraft in this configuration? This is not an AI generated image. They actually do fly like this close to each other. From the cockpit, they can see the other cockpit. So what kind of accuracy of controls are required? All of these things you start thinking of at this stage. The stage after this is where you start deciding, now how do you hold this aircraft together? Everything has to be rigidly held in place. There shouldn't be too much deformation, or the aircraft shouldn't break up in the flight. This particular image is a cutaway view of a HAIL UAV. It's a cutaway of the Global Hawk UAV. And you can see inside all these structural elements that are housing the contents of the aircraft. For example, this region here is a fuel tank. On top of this, you can see the engine housing has been installed. So some, some structures to take the thrust of the aircraft are present here. There's a landing gear. So you start working out how strong or how stiff or how compliant the structures need to be. This is important at this stage because now you start figuring out what the weight of the aircraft is. The weight of the aircraft is now tied back to the aerodynamics process. Many times something that is known as design creep comes in. So you started off with a guess value of your weight, but you
I
ended
think
up at
the screen
Yeah, I
got
think the
unshared
screen
again.
got unshared.
okay, let me share it again. Thanks for letting me know. So maybe you start off with a guess value of weight, and then you end up with something heavier. Then you modify your aerodynamics again a little bit to match that weight. And then it's a cycle. Hopefully, this cycle will converge for you. Sometimes it doesn't converge, in which case you throw out this design and start a new one, right? There are ways, fortunately, today where you can quickly iterate these designs. There are various tools available where you can, put these into optimization frameworks, have a multidisciplinary kind of design structure in which you put these things, and your guess values keep getting better. At some point during this process, you also need to figure out what kind of engine you want. Is it a jet engine? Is it a battery with a drive and a propeller? Or is it an IC engine? Or is it like a turbo shaft or a turboprop engine? What is the weight of this propulsion system? What's the thrust to weight ratio? What's the power at which it operates? How much fuel it needs to operate? What energy content you need to carry? Does it fit in that airframe which you made? So now you're getting a flavor of all of these are now actually a circle. You have to figure this out, plug it in, recalculate aerodynamics, come back, see if you need more power. Okay, so this is again part of that cycle. At some point in that cycle, you also have to check your stability. And the basic fundamental requirement is that you should be longitudinally static stable, in which case you need to have your CG ahead of your aerodynamic center. So now there are ways to calculate how far this distance needs to be, how stable you want the aircraft to be. Do you want a very stable, smooth aircraft, or do you want something that's hyper controllable and quite maneuverable aircraft? So the stability margins will decide what your design CG needs to be. Along with this, of course, you also need to figure out how you're going to achieve maneuvering or this kind of stability that you want. What is the avionics configuration that goes into it? And of course, there are various architectures available for controlling and different You'll be hearing a lot about this, I'm sure, during the Robotics Café series. So you need to figure out how exactly you want to control the aircraft. And in order to do that, what all needs to be on board the aircraft, what all needs to be on the ground. Remember that there is no pilot in the aircraft. So now you also have an additional responsibility of transmitting information from the ground to the air. So the way these two talk to each other, the way you send a command, the command is acknowledged, sent back, and that's how the loop with the pilot or with the ground control is established. So this loop also needs to be designed in a way that it meets the customer's expectations. For example, if you had the cyclone monitoring kind of application, what is required is that you need to send back pressure and image data back to the base, maybe at NASA, and they crunch the numbers and say, okay, now position the aircraft 20 kilometers to the east and collect data again. So this kind of data telemetry is required in real time, and then you need to calculate how much bandwidth you need to provide to transmit that data and things like that. So this is the point in the design where you need to freeze all this, because of course everything comes at a weight, and weight is a premium on the aircraft, like you saw in the design loop process. Once you are sure that all this works, now you go into manufacturing. Unfortunately, there are a lot of differences between design and manufacturing also. So let's say you decide that the weight of this aircraft is so-and-so, and it has these 5 avionics components that sit inside. But what about the weight of the wires that were supposed to be harnessed inside the aircraft? Did you factor them in at the early design stages? Or did you discover in manufacturing that now you are suddenly X kilograms heavier? So now it's your awareness of how the manufacturing data is going to be fed back into your design to optimize how close you can match your ground estimates with what you are actually manufacturing. This particular picture is a picture of a very famous Turkish UAV, which has become very popular in the last few years. And you can see the amount of wiring and the amount of messy stuff inside. Although there's no pilot, but there's a spot where the person is sitting inside. You can see that there's a spot for a satellite dome to be introduced. So during the manufacturing process, you also start now thinking of things like how expensive is this aircraft to manufacture. Just the materials of the aircraft may cost you.
We can't see your screen.
Okay. Sorry about this. There seems to be an issue with my network. Okay, so let's say that just the cost of the materials of the aircraft, maybe the composite in the wing, maybe the avionics, maybe the wiring, the landing gear, if you just add and make a bill of materials of all of this, maybe the cost is X. You can't sell this at X. Of course, you want a profit. You'll put some Y percentage of profit over it. But there's a built-in cost now also, apart from material, of the amount of effort that you put into making something, right? So the manufacturing processes, the shop time, every hour that you spend in the factory is expensive, like because you're running so many facilities around. You may need to run some specific processes, like you need autoclaves in the case of composites. You need particular machines. You need manpower. You need to pay the salaries of the people who are manufacturing. All of this goes into the cost of the aircraft. There are good economic models available to estimate the flyaway, what we call the flyaway cost in aircraft design, which includes all of these costs. And of course, there's also a cost of R&D. The R&D component also of the aircraft has to be worked into this cost. And then you have a prediction of how many aircraft you're going to sell in the future. Let's say you have 5 customers and each of them is going to purchase 20 aircraft from you. You're going to sell 100, then your profit margin could be something. If you manage to sell 1,000, your profit margin could be something else. So this math and this finance also happens around this time in the manufacturing stage itself. Prototypes are typically much more expensive to manufacture because the cost of the R&D is higher. But once you're in serial production, typically it's observed that the price of manufacturing comes down. Now, of course, before you even get into that stage where you're printing out 5 aircraft per month or 500 aircraft per month, Before that, you need to be sure that the aircraft is doing what you expect it to do. And this is the most exciting stage of the process, frankly. These are real pictures from some testing that we do at L&T. The picture on the right is a setup for hardware in loop simulation. It's called a HILS. You'll hear this term a lot. In the hardware in loop simulation, basically what happens is you want to check whether your hardware is operating the way you expect it to in flight without actually taking off. So what you do is you run a model, a mathematical model of the aircraft as if it's flying. You make the aircraft pretend that it's flying by giving certain sensor inputs to the aircraft. You give it altitude, you give roll, pitch, yaw angles, you give, drag. You give some of these numbers to the aircraft and see how the aircraft responds in this simulated flight. Actually, the control surfaces will move, the engine will be fired, the aircraft will try to tilt, the landing gear may be deployed. All these things need to be tested on the ground before you ever get into the air. Mainly, why you need to do this is, see, if you're building a ground system or you're building a car, let's say, if the car breaks down, you can just pull over on the side of the road and fix it and then start going again. But in the aircraft, there's no such option. If something breaks down in the air, you're going to crash and you'll lose the plane, and perhaps, you don't know what you'll fall on the ground. So this process of testing is extremely rigorous for UAVs. And especially as the size of the UAV increases, this testing becomes more and more critical and also involved. The kind of details that you need to check. For example, you may need to check whether there is some electrostatic discharge occurring in the fuel tanks, for example. There are so many things that could happen in flight. So you basically simulate errors, you simulate accidents in the flight, and you see how the aircraft responds. So of course, your control loops, your software, your logic, and your interlocks, all of this is tested at this stage on the ground first to ensure that everything works. And then you take to the air. And when you take to the air, you also fly in very controlled environments where, God forbid, if something goes wrong, you should be able to recover your aircraft safely and without loss of life to your team or to anyone else around. On the left is a photograph of my co-pilot and me at one of our test ranges where we were flight testing the Tir UAV. So this process, frankly, is a process of validation. And this process is actually the most time-consuming and also the most expensive part of the UAV development process. But your job is still not done, because at the end of the day, you want your customer to be able to use your fleet of UAVs. If they buy a fleet from you, this particular photograph is from one of the recent conflict sites. And when you're a customer, you're an Air Force, or let's say you're an agricultural drone operator who operates a fleet of 20 aircraft. Now, questions like spare parts, maintenance schedules, how often do I need to change the gasket of the engine, for example? These kind of questions need to be answered. And not just that, now it's also a matter of how much availability is there of the aircraft. Let's say you have a fleet of 20, but the aircraft is so difficult to maintain that at a given point of time, only 10 are operational. Then it's not giving value for money to your customer. But at the same time, you also want the aircraft to be safe and functioning well. So now it's a way off. So when you look at the final product of a UAV, actually, your users your customer is most interested in this aspect. It's like us buying a car. We ask two questions when we buy a car. Kitna deti hai? What's the mileage? Does it perform well? And what's the maintenance cost? These are the primary concerns. Everybody asks various other questions. How does it look? Is it big? Does it fit everyone? All these things. But at the end of the day, you're worried about how much you're going to be spending to maintain that car. So this is something like that. This stage is also fairly time consuming, and it has to be done along with you and your customers' confidence also at the same time. So now the question is, can this be done in India? I'm proof of this. You can see this.
Tanvi, your
Okay, I'm resharing it. I'm resharing it. So can you do this in India? That's the question. So yes, the answer is of course yes. There are many career paths available in India for anyone who's interested in this field. I cannot possibly tell you how much the UAV market has exploded in the last 10 years. I've been in this field for like 15 years now, and the amount of career opportunities in this is shot through the roof. And there's no way I can give you a summary of all of them in one place, but I've attempted. Of course, my employer, L&T Defense, now L&T PES, we build UAVs ranging from 3 kgs to 3,000 kgs. We work with various Indian defense customers. We work with DRDO and various labs, and we try to fulfill their UAV requirements. This particular UAV was designed on scratch, from scratch, by my team and myself. We have design offices in Bombay, Bangalore, and then production centers at Coimbatore, Pune, Surat, various places across the country. Like this, there are several other private players who are into making both big and small UAVs. There are the Tatas, Mahindra, Bharat Forge. There are so many big names, Bell. There are many big names in this industry here in India, and they are looking for UAV designers and people with the skills for this. The Make in India policy, of course, has had a big role to play in this. The fact that Indian airspace is also opening up, and the digital sky platforms are more open now. It's possible now to register your drone, get it DGCA certified or Semilac certified, so that this drone is really world class. The policies are really helping in this direction, and not just that, the policies are evolving with time to meet the requirements of both the developers as well as the consumers. The other top employers in this field are, of course, government agencies. Government agencies like ADE, the Aeronautical Defense Establishment, based out of Bangalore. They have been working on a host of UAVs for the longest time now. They've worked on the Rustam 2, Rustam 1, Abhyas, Laksha. The latest one is Ghatak, where L&T is their preferred partner. And so there's a host of UAV development programs always going on at ADE. Surprisingly, there's also some work happening at ISRO. ISRO also has a fantastic aircraft design department, a UAV design department also, where they work on different types of UAVs. They sponsor projects at various educational institutes, for exploration of other planets. There's a Mars exploration UAV, there's a Jupiter one, and there are so many other projects that are happening by ISRO in the unmanned domain. NAL at Bangalore, the National Aerospace Laboratories, they are currently at the forefront of solar UAV research, not just in India, but also in the world. This is a photograph from, I think, last year, where they actually tested a solar-powered UAV at Chitradurga test range. They also get into the entire process. It's a fantastic program that they are running. And then, of course, there are the startups in the UAV domain. These guys are the big guys. There are so many. This infographic doesn't cover them all. These are just some of the major cities: Mumbai, Bangalore, Delhi, Hyderabad, Chennai, Pune. Then there's Indore, Bhubaneswar, Calcutta, you name it, Jammu. Everywhere there is multitude of these startups, and all of them are trying to address different types of customers. Some focus on agricultural drones, some focus on let's say highway inspection drones, some focus only on military drones, some focus only on helicopter drones, some focus only on engines for drones, some focus only on motors for drones. There's a whole ecosystem out there right now, and I'm sure that whichever city you're
the
in,
screen is unshared again.
okay, I'm sure that whichever city you're in, there's most certainly going to be some presence of a startup that's in this field. Some of these startups actually aren't even startups anymore. They are almost, they're big companies. Idea Forge, they are listed. Garuda Aerospace is about to be listed. So these guys are like really, really on the forefront of not just the Indian scenario, but also on the global scenario. And yeah, so basically that's about it. There is a bunch of laws also which are present already in the country, which govern how these UAVs should be developed, tested, flown, and registered. You need to be a registered design agency with these organizations also. You need to be able to prove that you have all of this due diligence in place before you can even get a certificate to be in the air. And of course, even with the civilian domain, there's a whole lot of progress in the last 3 years on registering your UAV before you fly in free airspace, so that even if you're flying alongside manned aircraft, there is no conflict, and you're able to stay safe and keep others safe as well. That's why the regulations and laws are there. These regulations are also evolving with time and getting better. India is one of the countries which is quite, I would say, quite advanced in terms of these regulations and laws. And then, of course, for those with the geeky and academic bent of mind, I've only put some IITs here, but there are so many other, I think I missed out putting ISC and ISER also in this. There's so much work happening in almost every academic institute. I know that Plaksha is also doing some great work in the area of UAVs. And so there is a lot of funding also, and a lot of interest, a lot of expertise in Indian educational institutions. And there are more and more ways in which industry and academia are able to tie up. Most of these educational institutions have, let's say, an incubator or a research park where they can, they help startups begin and continue their work in their particular R&D domain. And with that, I'll end my part of the talk. We have quite a bit of time. I'm happy to take questions from you guys. Here is the link to my website. And you can go to this website. There are some nice things over there about how to be a UAV, how to get into this industry and things like that. Some good resources are there on here.
Tanvi, thanks for a great
Open to
talk and
questions.
a lot of insights from the industry aspect. I think all the students would have really enjoyed not just making it for research, but making it to sell it to customers. That's maybe exciting, more exciting to students. Yeah.
Yes.
So any questions? We're open for questions. If you have any questions, please unmute yourself and you can go ahead with the questions.
Tanvi, can I ask a quick question there?
Yes, of course.
Yeah, I should be the last one asking as the host, but okay.
You can inaugurate it as well.
Exactly. Yeah. Well, thank you. So Tanvi, so actually it's great to see the programs in India. I mean, unfortunately, I suppose we don't advertise our programs as much as we probably ought to, right?
Yes.
But in all of this, one thing I'm very curious about is what about engines? I mean, how far are we with developing maybe gas turbines or good quality electric engines for the kind of scales that, for example, for Tir or similar scaled airplanes? Where are we at with engines?
Yes. Excellent question, because you've actually hit the nail on the head as far as this whole push for Make in India and indigenization goes. The indigenous value of a drone is counted in terms of the cost of the various components that go into it. And presently, if you look at most of the drones, even the most indigenous one that you see today, the cost of the engine will be, at least 20% to 50% of the aircraft. So we've kind of hit a ceiling of how much we can indigenize things in terms of a percentage because of the engine. So it's a big issue. And this issue has been spotted by a whole lot of people in India, and they're working on it. For example, for the Tir class of UAVs, L&T has cooperation with a startup based out of IIT Delhi, and they are doing some fantastic work in development of a micro turbojet engine with a 40 kg thrust kind of thing. I understand that there are at least 3-4 other companies, some of them also incubated at IITs, some of them funded separately, who are working on development of jet engines. Now, if you look at jet engines, that itself is such an involved science and almost an art, you can say. And there's so much of instrumentation you need to do, very rigorous testing also that needs to be done on these engines, because of course if the engine shuts down, then that's it for the plane, So now that's about jet engines. In terms of IC engines also, there are at least 3 or 4 really advanced stage developments that are going on in the country. There are several companies in the south of India. There's UMS, and there's, I think Bharat Forge is also doing some work in this. There are quite a few companies who are getting into the IC engine domain. And as far as the electric propulsion side of things goes, BLDC motors is like the mainstay of for UAVs. And there are a whole lot of startups across India. Just this morning, I spoke to 3 such startups actually who are working on this. So it's like that market is quite good. Propellers also, there are quite a few people who manufacture this in India. The manufacturing processes are becoming much more, I would say, easier to crack nowadays because of 3D printing and availability of different kinds of materials also in India. On the higher side, like when there are larger engines and larger, more expensive engines involved, there is still much to be desired. Especially with the very large engine ranges, like for a Predator class, or let's say for a Ghatak class. So there are options available, but still, so far we're still relying on foreign engines. It's all, actually, if you look at it, my opinion is that it's an economic game, because when you sink that amount of money into developing an engine, because the amount of reliability you need to work in is so high, that you also need to be sure of selling that many engines. So you are right. So for smaller UAVs, there's a bigger market right now. So you can build engines for these smaller UAVs. And hopefully slowly as the industry grows, I mean, I don't know whether it's slow or fast, but over the next decade, I'm sure we're going to see a very, very exponential increase in manufacturers for engines of all classes in India.
Okay, so that's really interesting. I mean, the sheer diversity is quite great to see. So 2 things I should probably add. So the first one is a bit of an anecdote here. So, I mean, I'm now based here in Monash University. And what's interesting is, just as you have these inter-university competitions with drones, there's also an formula, I think it's for Formula E or some such competition,
Yes.
student racing. And I think we are probably one of the few universities, if not the only university, which manufactures its own synchrotron motors right now.
Really? Wow.
Yes. Yeah. So not synchrotrons, man. Anyhow, they're the only ones that actually do that. So what was very, very interesting was the fact that, a bunch of students with maybe a few dedicated lab assistants could actually pull this off, and as a multi-year thing was sort of really great to see. And then that sort of led me to wonder, about, again, in the Indian context, I mean, even with the Kaveri, the sense was the engine was working. It's just that once you pushed it to, the higher end, I don't know if this, at least rumors had it that they had compressor surge problems. I don't know if that's entirely true, but that's what I remember hearing as an undergrad. So my sense always was, it seems like we have the tech in India, but maybe it's not optimal enough to compete with the likes of GE or so. And that raises a question, in the national interest, can we afford to take that little hit, maybe 10-20% hit, and actually go with Indian engines?
Right.
So,
I think a lot of people are now realizing this, because once you crack it, then there's a huge market available now. Perhaps maybe 10-15 years ago, the market for drones, UAVs was not that big. But now the markets are growing, and it's becoming much more, it makes much more business sense to get into this now. And the perceived value of it is increasing. So yeah, I mean, things are quite different now.
I think the conflicts are helping this.
What?
Geopolitical conflicts are helping drones.
Yeah.
Yeah, if you look historically, technology always begins with the defense domain and then enters into the civil domain. So yeah, I mean, if you look
I
at
don't
it,
think
you
we
can always look
apologize
at
for defense, right? I mean, I don't defense. People who sound very apologetic about defense. I mean, that's a very natural thing. It's okay.
yeah, sure.
It's okay. Thanks.
Any questions from the students? Maybe we will take questions from the students.
Yeah, I had a quick question.
Yeah, please go ahead.
Hi, thanks for the exciting talk.
Rahul.
So, you showed a slide which pointed out, okay, you can optimize your design guesses. So, can you tell how that process goes, or what methods generally you use, or any tools like CAD or some ANSYS like models or softwares which you use? Like that would be great because that's something I'm like interested in.
Good question, Rahul. You've spotted actually the most exciting part of the process, at least to me. Um, Frankly, the your question actually is in two parts, so I'm going to answer it in two parts. One part of it is how do you do it, and the second part of it is are there tools to do it. The how actually is not about the geometry of the aircraft or about even about how much lift is being generated or even how much thrust is being generated. This is all about starting with what the customer requires. So you need to cultivate this way of thinking, which is also called design thinking. You'll hear this word a lot nowadays. In the case of design thinking, what you have to do is you have to kind of prioritize what are the problems that you're trying to solve and see if all of them can be solved at once using one configuration, right? So the way to do this is you ideate. You build, like, I wish I could show you. I don't have it right now, but uh, you have to ideate a whole lot of ideas. Let's say, like, you want to build one configuration, but you sketch at least 20, 25 of these configurations, and you think about, okay, if let's say I'm in building, like in today's world, it's an interceptor drone. So if you're building an interceptor drone, shouldn't it be looking like a bullet? Like, doesn't it need it has to go like a bullet and hit the target because it's a very high speed thing. So start from a grain like that and say that, okay, this is a bullet which has to go at a very high speed. In order to go at a very high speed, now it needs to have some kind of propulsion. So let me see different ways of adding propulsion. I can add a rocket motor into it. I can add 4 motors into it. I can add a jet engine. I can add this. Then now when it reaches the point over there, it needs to carry something. It needs to see what's there and then be able to finally hit it. So how is it going to look at it? Is it a camera? What kind of camera is it? Is it infrared? Is it daylight? What is it? So now you start looking at various configurations of where I can keep this camera. Should it be on the nose of the aircraft? Should it be on the top of the aircraft? Is it going to do some maneuver and then I place the camera there? So this kind of thinking is it can. I mean, I'm not aware of any tools that can do this yet. There are ways to ideate, of course. AI nowadays helps you ideate and it helps you brainstorm. And there are ways to, there are frameworks available for design thinking as well, where you can, sit in a group. It's always better if you sit in a group to do these kind of things because what ideas I may have are not the ideas that you may have. So this is actually how the configuration review goes. Now, if you look at it in terms of really how you're meeting the customer specifications, there is one particular science that's been emerging in the last 5-10 years, which is going to become very important now. It is model-based system engineering. What they do is they start with a system requirement specification, where every requirement, whatever I showed you in that ConOps, is sort of laid out and mapped to every single requirement. For example, the requirement of being able to loiter at 50,000 feet, the one that I showed you, that can be mapped to so many things. It can be mapped to the engine performance, to the airframe weight, to the fuel, to how much fuel you're carrying for 24 hours. So it's a map and it's a web. And when you change one parameter in one corner of your model, all the other parameters in that change as along with it. So this model-based system engineering is a tool or a methodology that's become very popular now in the last maybe 5 or 10 years in the UAV domain, especially. In this, what the various modules that get incorporated in this are, of course, there'll be a CAD component. There may be a CFD component, there may be an FEA component. There could also, of course, there will also be a control system modeling component and maybe an engine model. So all these various modules can be used. Now it's your module of choice, what you prefer. For example, if you're trying to solve some particular nonlinear dynamics, you need a particular kind of solver to solve it. Or if, let's say, you are doing low Reynolds number solutions, then you need a different kind of solver for it. If you have like a very high strain rate phenomena, you may need explicit FEA. You have regular stuff, you can go with normal FEA. So now it's just a choice. Now it's all these modules and interacting with each other, and you pick your module of choice and plug it into the system model. So that's kind of the approach that's there in the industry right now. If you have some specific query about like what do I use for CFD or something, that this kind of data is really available online. There are some aircraft design tools like there's OpenVSP, which is based on a NASA framework that they have. There are some MATLAB-based frameworks like Cesium, and many new things keep coming from various universities abroad. You can keep checking those and stay abreast with what's happening in the field.
Yeah. So, our just a follow-up on that. So, is the like are these tools the same tools like which can give you like an integrated approach towards design, or you have to like, as you said, divide in the different modules and then kind of integrate them? So
There are different ways to do it. You may have some tools which are super incorporated. Nowadays, it's possible to even write your own master code which incorporates everything. Like you can run ANSYS through PyMVDL, and you run your CFD solver through another, and have one Python wrapper over everything which does this integration for you. So it's possible now. There are tools available which also do this. I think the University of Swansea has been developing one such Python-based wrapper. University of Southampton has a MATLAB-based wrapper like this. So there are quite a few. There's a lot of work going on. But if you look at the majors, like the big industries, you look at the Boeings or the Airbus or the General Atomics, they typically have their own framework. And at L&T also we have our own framework. So because that is something custom to what we are building and our processes.
There are some questions coming online in the chat.
Yes.
So, Naman, do you want to unmute yourself and ask the question?
I actually, this is
Oh,
Shashank. I
sorry,
just have a
Shashank.
quick follow-up on that. I just wanted to understand if, like, in the US, tools like SysML and etc. are being used, but in India, do we have these penetrated?
Yes, they are there. At L&T, we use MBSE. We are using this approach.
Naman, do you want to unmute yourself and ask, or should I read it? Okay, I'll read it. So I don't know much about, this is a question from Naman Tyagi. I don't know much about drones. I am just getting started studying them. Something I really struggled with is power. A lot of times, especially beginner projects, the config revolves around what your power source is. But I think on an industrial level, this is not possible as the features come first. How do you decide what is possible and what is not, considering the material limitations and power limitations? That's one question. And the second question is, are things like batteries custom made in some projects?
I think both the questions are related. The first question is about how do you know that you're really getting the amount of power that you thought you would? And this is a question of what's the quality of your propulsion system. I'm guessing that you are talking about electric power from like electrically powered systems, and which are typically run by LiPo systems these days. There are other chemistries also that are being used, but the lithium polymer is the most widely used. So I'm guessing you're talking about that. Now, where the lithium polymer battery performs really well is in a regime where you have a constant kind of current flow over a period of time, but not when you are drawing very large amounts of current for small time. So perhaps you want to look at some other chemistry which is able to generate this kind of power in this duration. So it's a question of how you're selecting. You can look at LiFePO batteries, LiPo batteries, even lithium ion to some extent is being used. And frankly, for most of the applications that you see out in the industry and all the successful UAVs that you see, standard off-the-shelf batteries may or may not work. Okay, so you end up developing your own battery pack, your own battery management system, which is very important, so that you know the health of every single cell on your battery, and you are assured that in flight one of your cells is not going to conk off and give you trouble. So yes, it has to be a custom solution. The world is increasingly moving towards this. But there are some exceptions also. I mean, where there is low cost and this expendable drones category of things, there people prefer to just use an off-the-shelf battery just because it's cheap and live with the problems that come with it. So the point is, whenever you get into your design, go in knowing clearly what your end requirements are going to be. If you know that you're going to draw very high currents, design for that. At the first stage, select a battery with the right rating that you require. There are a lot of good battery models available also. If you're using some tools like MATLAB, there are battery models also available these days.
So there's another question. It's more related to career in UAV system sector. So as a BTech EE student looking to head into control for higher studies, is a master's degree the correct amount of education to head into UAV industry, or are there better opportunities after doing a PhD in this sector?
That's a tough one. I mean, see.
And people who have done PhD will say do PhD. That's
exactly. And I know PhDs who are also struggling to look for jobs. So, frankly, there's no correct answer for this. I don't know what to say. But you have to understand that to work in the industry, you need a very different mindset. It's not that the strongest math wins in the industry. Sometimes you also have to be good at a host of other things. You need to be a great communicator. You need to be a great team worker. You need to be able to zoom out and view your project, on a larger level. You need to have good time management skills, good discipline. So there are so many other aspects other than just your BTech or MTech, which matter to get a job in the industry. Sometimes you just need experience in a particular field. Let's say like batteries, for example. You gain a lot of experience in batteries, and then that's how you end up in a UAV company. So there are multiple routes. It's about finding your slot and how you can contribute to the industry.
Thanks, Tanvi. I have a quick question related to the research part, like about the physical simulation that you have worked with, right? Like these
Yes.
simulators are very expensive to build your own one, right? Are there any suggestions that you have which can actually help with smaller setups, or like building smaller setups or in a small lab or small startup? If students want to build their own physical simulation, how can they do that? And any
Actually, I would probably disagree with that. These systems are not, they need not be very expensive. It depends on what fidelity you want your setup to be at, right? If you want a super high fidelity thing, which can go to space first time right, then of course it's going to be expensive.
No, but when you're pitching it to a customer, what is the expectation in the current world, and what do you think could be done?
Excellent point that you are making. If you look at the way certification works these days in India and also abroad, most of the time they're satisfied to hear that your UAV is going to have a fairly good amount of reliability. They're not looking for space level reliability or very high level reliability. Maybe even about maybe 5-10 years ago, it was more difficult because of the kind of chips and the kind of computing power that used to be available on board. In that particular weight budget that is there for UAVs. But currently, at least the way avionics looks from like the electrical perspective, it's fairly easy to achieve very high levels of reliability without having a very, very expensive setup. If you have a particular requirement, let's say you have a ship-based UAV or something which requires a specific kind of simulator in a roll pitch yaw simulator or something like that, then I can understand. But most systems that you see, like maybe 95% of the systems don't actually need such an expensive setup. It can be very well set up in a laboratory or in a small startup kind of environment.
Thanks.
Um,
Shashank, you had a question?
Yes. I had a couple of them. I actually wanted to introduce myself. I lead the robotics program in Plaksha, and my work is on drones in agriculture and some bit in defense as well.
Nice to meet you.
Yeah, nice to talk to you. So my question was around. I think one of the categories you probably didn't talk about was around swarms, right? So how are what is the status in the Indian industry around that in terms of both research as well as implementation? Yeah.
Okay. There are several government agencies working in this area as well as private players. Among government agencies, of course, there is the big one is actually currently the CATS Warrior project, which is supposed to be a manned unmanned team along with a manned aircraft. So it's a swarm of UAVs that go along with manned aircraft as wingmen. So this is one project that's going on, being fronted by HAL, and they're working along with ADA for these things. Apart from this, in the private industry, there's quite a few players. L&T is also in this. We are currently in the process of testing some of our things. We have a bit of IP also that's there in this domain. There are various small startups who are working on swarms right now. Now, the thing is, how do you define a swarm also? Is it, there are so many different types of swarms. Professor Sujit is here. The interpretation of a swarm could be different based on your end use. What kind of a mission are you trying to achieve, and what kind of a swarm do you need for that? This understanding is evolving in the community in swarming about what constitutes a swarm, and because the users are just getting used to this concept of having hundreds of UAVs coming in. There have been events in India like Opsindur last year where it became a little clearer to our Indian armed forces what a swarm needs to look like and what the requirements need to look like. So it's definitely growing. It's quite nascent because the end use cases are still evolving. From the research point of view, I leave it to Professor Sujit. I mean, he's the expert in this field.
Great, thanks. I would love to separately connect with you as well on.
For sure. Thanks. Are there any more questions?
Hey, we can take one last question, I think. If anyone.
Hello, ma'am. This is Prashant here.
Hi, Prashant.
Sorry.
Yeah, ma'am. Ma'am, my query is that in the recent scenario of defense procurement around like all the private players that have participated, out of 100%, 95% of the systems have been rejected due to use of Chinese components. And it will be a major threat because like all the controls have been manufactured in China only.
Right.
Like all the controls that what we use today, all the offshore components. So like what is the contribution that only 5% of the like defense procurement have been selected? Like what are the changes did they might have done in order to safeguard the national interest?
I cannot comment on what others are doing because I'm not the right person, but I know what L&T is doing. We have our own flight control computer, which is developed on scratch. The chip was designed by us. So maybe the value of the components would be lesser, but the amount of engineering work that goes into making this is what you actually add over it. So you have your the hardware. If you look at the price of these components, maybe if you break them up, the hardware is one component. It's a small component, but then the software, your controls, the algorithms, the safety interlocks, the logic, all of these things is actually a very large expense in development because you need to try it in flight. You need to log hundreds of hours of flying for, let's say, a flight control computer to be safe enough to be certified. So that's probably one of the reasons why a lot of people are not able to crack this thing, because it requires a lot of patience and a lot of money also. As far as other components go, there are Indian options now available. I was referring to propellers, BLDC motors, propulsion systems. A lot of these things are actually Indian with Indian content. A lot of manufacturing also is being done in India. So things are definitely looking up. But of course, with the chips thing, India also has a national chip mission, which is trying to sort this thing out with the government support and with a lot of funding to various agencies. They're also looking at solving this, cracking this chip problem also. So I would say the next 10 years is when things change, and let's see how it goes.
Ma'am, thanks for answering the query, and just a small follow-up question. Like,
Yes.
what is the role of distributed robotics as well as cyber physical systems in the coming era?
So cyber physical systems are already there now. In the UAV domain, actually, if you look at it, it's already kind of in a way a cyber physical system, if you look at it. But of course, the kind of missions that customers are now thinking of are demanding more and more of this collaborative swarming and distributed intelligence kind of things which were not possible before, which probably didn't even occur to the users before, are now occurring to them, especially when we look west and we look at the different kinds of uses that they've been putting their UAVs to. There are some programs that are running with the Indian Armed Forces in both these areas. So I would say again, like it's anybody's guess which direction it goes. Right now, it's the technology readiness of the country as a whole is on its way.
Thanks a lot.
Okay.
Okay, we can take one final question, maybe.
Anjaneya, sure. This is the
Anjaneya.
final question.
We had, like you had mentioned, that there are now indigenous hardware, like L&T is also coming up with for flight control. But the actual firmware that runs on these things, generally we see that like PX4 or Ardu Pilot are the major players in this. So it's very tough to create a full firmware, basically. So is there an indigenous attempt now to create a full end-to-end firmware for at least like a quad rotor? Or how is this sector evolving?
So the L&T system does not depend on any Ardu Pilot firmware. It's our own firmware. And I believe we are not alone in this. There are quite a few companies who are working in this. The basic thing is when you want to come out of, because Ardu Pilot is a extremely open source and highly crowdsourced kind of development. So, it's already been matured over so many years. And this is a thing which I was also answering when Prashant was speaking. It's like, the amount of time and money and patience that you need to put into developing that's something outside this, because we've been through the cycle. It's massive, really massive. And it requires a lot of financial, staying power. It requires really, really good engineers who know what they're doing. It requires a lot of software know-how and architectures, like organizational architectures also, to be able to make something like this happen. So so I mean, a lot of the flight control manufacturers, as you rightly said, are based off Ardu Pilot, but that's not to say that nobody else is doing it. I mean, we are an example of that.
Thank you. Thank you, Tanvi. And I
Thank
think
you,
it's
Tanvi.
time to land the flight. And Sujit, I hope you don't have a question.
No, again, but I have the question, but it's okay.
You can go ahead. Sorry.
Go ahead.
Okay, just on the other part of, since you have done a lot of experiments, right? So what was one of the worst or best experiment that went well and didn't go well, so that everybody knows that what goes behind the scenes, right?
Yeah, I mean, in aerospace, there's a saying that takeoffs are compulsory, are optional, but landing is compulsory. It's always your first landing which is very, very memorable, because when you get your aircraft back in a good condition once you've done your tests. So it's a fantastic experience for the entire team when you've achieved your mission and you've landed for the first time and you've done it, because a lot goes into it. there's a lot of, when especially I've had experience in leading a team. So maintaining morale over failure, and failure is a part and parcel of it. You have to fail a lot. And then finally that one landing that happens, which is like it, and you've ticked all the boxes and you won finally, So that's the thrill of that is completely different. And it's not just for UAVs, it's in any domain. Like the first success that you have, you never forget that.
Okay, nice. Thank you.
Thank you. Let's all thank the speaker once again, and it was very insightful and very good talk. And thanks for taking your time off and giving us a great talk. Yeah.
Thank you.
Thanks, Tanvi.
Thank you all for joining, and I hope everyone enjoyed. Sorry, Tanvi, you can
I just
end
wanted to
it with your last words.
people, and I mean, you've all seen my website. You can get in touch with me also. I'm open to that. On the website, there are ways to get in touch. So that's it.
Thank you.
Thanks,
Thanks
Tanvi.
all for
Thank
joining.
you.